Bismillahirrahmanirrahim. Exercise 12.1, question number 1. Prove that the center of a circle is on the right bisector of each of its chords. So we have drawn a circle here, and we have to prove that its a center O is on the right bisector of its chords. We have taken 3 points A, B, C, and we have drawn chord AB, AB and BC. And we have to prove that O is on the right bisector of AB and BC. So as AB and BC are the chords of the circle, it is given to us in the question. And it is also given to us that there are right bisectors on it. So PQ and RS, these we have drawn the right bisectors of these 2 chords AB and BC. So now we will prove it by gathering certain statements and by mentioning certain reasons about it. As you can see in the diagram, that OA and OB, which are the distances from some point O on the right bisector of AB. The right bisector of AB is PQ. There is some point O on the right bisector of AB, and that point P, that point O is actually the radius of the same circle. So that point OA and OB, the distance OA and OB is the same. And the reason is the radii of the circle. Similarly, on the chord BC, we can say that OB and OC are congruent because they are also the radii of the circle. So from these 2 results, we can say that OA is congruent to OB is congruent to OC because all are congruent to each other. And as we have seen that because O is on the right bisector of the AB and BC, and it is also passing by this result, OA is congruent to OC. We can mention this result separately over here. OA is congruent to OC. So if some point is equidistant from there is some point and that is equidistant from the endpoints, we know that according to the theorem, it is on the right bisector of it. So O point, which is equidistant from the endpoints of the chord AC, so it is on the right bisector of the AC. So O was previously on the right bisector of AB and BC, and from this result we have proved that it is also on the right bisector of AC. So it is proved that O is on the right bisector of the all of its chords. Now come to the next question, question number 2. Question number 2, the statement is that where will be the center of a circle passing through 3 non-collinear points and why? We have taken a circle and this is passing through 3 non-collinear points A, B, and C. A, B, and C, and its center is O. They're asking that where will be the center of the circle passing through 3 non-collinear points and why? So the circle is passing through A, B, and C, and O is its center, and we have drawn a chord AB, and we have taken a point D and let this be the midpoint of AB. And then we join this D to O, and also we will join this O to A and B. Now we will take the correspondence of these 2 triangles in which we have also taken 2 angles, angle 1 and 2. Now we can see from the diagram that OA is congruent to OB because they are the radii of the same circle. So OA and OB are congruent. Similarly, we can say that OD and OD are congruent because they are common, and AD and BD are congruent because D is the midpoint, as we have taken in the construction. D is the midpoint, so AD and BD are congruent. So we have gathered 3 facts about side postulate and of these 2 triangles, and so these 2 triangles are congruent. The triangle AOD and BOD, when they are congruent, we can draw certain results, and the result that we are drawing is that angle 1 is congruent to angle 2. These are the 2 corresponding angles in these 2 congruent triangles. If we add these 2, we can see that by adding these 2 we get a straight line. So the sum of these 2 is 180 degrees. So as these two angles are same, so I can replace 2 by 1. So 2 times 1 is 180, and so angle 1 will be 90, and similarly angle 2 will be 90 because both the angles are same. So D was initially the declared as the midpoint of AB. We have taken it in the construction, and now it is proved that at point D there is an angle of 90 that is existing. So DO is now proved to be not only the bisector but a right bisector of AB. And so it is proved that DO is a right bisector. So O, as it is a part of DO, so O is on the right bisector of AB. So center of the circle. It was asked that where is the center of the circle? So O, which is the center of the circle, is on the right bisector of AB. Now we will move to next exercise. Question number 1 from exercise 12.2. The statement is that in a quadrilateral ABCD, AB is congruent to BC, and right bisectors of AD and CD meet each other at point N. And we have to prove that BN is a right bisector of the angle ABC. So according to the statement, we have drawn a quadrilateral ABCD. And in this, we can see that AB is congruent to BC. And the right bisectors of AB, AD, CD, they are meeting each other at N. And we will prove that this BN is the bisector of angle B. So for this purpose, we will join point N to A, B, C, and D. First of all, we have to draw the right bisectors of AD and CD. So we have drawn the right bisectors of AD and CD. These are the right bisectors. The first one is this one, and the second one is this one. So they are intersecting each other at the point N. And then afterwards, we are joining this point N to all the 4 points A, B, C, and D. We can mention it like this. We can highlight it like this. We have joined this N to these 4 points. Right? So now we can see that as ND and NC, as N is on the bisector of DC, so ND and NC, they are equidistant according to the theorem. Similarly, N is also on the bisector of AD. So it is equidistant from the endpoints by the same theorem as you have seen in the above result. So ND is congruent to NA. From these two results, we can see that NC and NA both are congruent to ND. So NC and NA both are congruent to each other. Now we will take the correspondence of two triangles BNA and BNC. Look at the diagram, BNA and BNC. In these two triangles, we have just proved that NC and NA are congruent. We have just proved it over here. So one result, another, AB is congruent to BC. It was given to us. And BN is congruent to BN. It is a common side. So we have gathered 3 sides. So side postulate, we are using it, and these two triangles are congruent. As if they are congruent, so all the corresponding angles are congruent. So angle 1 of this triangle is congruent to angle 2 of this other triangle BNC. So these are the corresponding angles of the congruent triangle. So they are congruent to each other. So the moment we prove that angle 1 is congruent to angle 2, and these two angles are the angles of 2 angles and the angle B, so we prove that angle 1 and angle 2 as they are congruent. So it means that this angle B is bisected. It is bisected, and it is bisected into 2 equal parts, angle 1 and angle 2, and it's proved that BN is a bisector of angle B, and that is what we had to prove, that BN is a bisector of angle B. So by proving that angle 1 is congruent to angle 2, we have proved it. Now come to the next question number 2. The bisectors of angle AB and angle C of a quadrilateral, they meet each other at O. Right. So we have a quadrilateral ABCD, and there are 3 bisectors. The bisectors of A, B, and C. They are meeting each other at the point O. these are the three bisectors. Right? We have to prove that bisector of the P, the fourth angle, that will also pass through the point 2. So for that purpose, what we will do, we will join this. Initially, we have drawn the bisectors of the angles: angle A bisector, angle B bisector, and angle C bisector, and they are all passing through the point O. And afterwards, we are joining this O point to the point P as well, and also we are drawing some perpendiculars. OT. Let me choose a different color so that it is highlighted. OT is perpendicular to this side. OQ is perpendicular to this side BC. OT is perpendicular to AB. OQ is perpendicular to BC. OR is perpendicular to PC, and OS is perpendicular to AB. So these are the perpendiculars that we have drawn over here. We can see that as a step of construction. Now we are going to prove it. We can see in the diagram in this portion, in this portion, we can say in triangle ATS, in quadrilateral, in the angle SET. We can say in the angle SET, where there is a bisector of A and there is some point O. On that O is equidistant. OS is congruent to OT because O is some point on the bisector of the angle, and it will be equidistant from the arms of the angle. And this is the statement of the theorem. So according to the theorem 12.4, OS is congruent to OT. Similarly, the same situation over here. OT is congruent to OQ. OT is congruent to OQ. Because OT and OQ, these are the distances from point O, and O is a bisector of B, and any point on the bisector of an angle is equidistant from the arms of the angle. Here the angle is angle B, there is some point O, and it is equidistant from the arms. The same reason that we are using over here, the same reason exists over here. And from these two results, as both the side OS and OQ, there is another result. So there's another result, that is OQ and OR. That is the same result. OQ and OR, they're also the distances from some point O, and O is on the bisector of C, and so any point on the angle bisector is equidistant from the arms of the angle. So OQ and OR, they are also equidistant. From all these results, we can say that from all these above results, OS and OR, they are equal. We can see that OS is equal to OT, OT is equal to OQ, and OQ is equal to OR. So we can say that OS is equal to OR. So OS and OR are congruent to each other by combining all the above results. So now come to the figure and see that where is OS and OR. Here we have OS, and here we have OS and OR. So OS and OR, once we have proved that they are congruent, so it means that there is some point and it is inside an angle P, and it is equidistant from the arms of the angle P. So it is on the bisector of angle P. This is the theorem, this is the statement of the theorem 12.5. So that any point inside an angle which is equidistant from the arms of the angle is on the bisector of it. So O is now equidistant from the arms of the angle. However, why we can say this? Because OS is congruent to OR, so it is equidistant from the arms of the angle. So this point O is on the bisector of the angle P. So it is proved that O is on the bisector of angle P, and we are using theorem 12.5 as the reason of this statement. So I hope it is clear. Now we move to the next question, which is from 12.3. We have to prove that by this question number 1, we have to prove that the bisectors of the angles of the base of an isosceles triangle intersect each other on its altitude. So there is an isosceles triangle, right? And there is a base of it, which is BC, as an isosceles triangle is ABC. And these two sides are congruent to each other, AB and AC, and BC is the base of this triangle. And bisectors of the base are definitely angle, we are talking about the bisectors of angle B and angle C. We have to prove that the bisectors of angle B and C, they intersect each other on its altitude. They are here intersecting on point O, and we will prove that this point O is on the altitude of this triangle. So first of all, we will draw the bisectors of the angles. We have drawn the bisector of B like this. We have drawn the bisector of C like this. They are intersecting each other at the point O. We will join this O to D, and again we will join this O to A, the opposite vertex over here. So AOD is now a straight line, we can see. Join O to A and D, and D is some point on BC. Then we will draw some perpendiculars. I'll change. There is some perpendicular OD, which is perpendicular to BC. And there is another perpendicular OE, which is perpendicular to AC. And this third perpendicular OF, which is perpendicular to AB. By these construction steps, now we proceed. As O is on the bisector of angle B, so its distance from the arms is equal. So OD is congruent to OF, right, by using the theorem. Similarly, the very same reason, as O is on the bisector of angle C, so it is equidistant from the arms. So we can say OD and OE is congruent. So by combining these two results, we can say that OE and OF both are congruent to OD, so they are equal. OE and OF are congruent. From this result, as we can see in the figure, that if OE and OF are congruent, so we have reached to this result that there is some point O which is equidistant from the arms of the angle A, and so this point O is on the bisector of it. Therefore, O is on the bisector of A. It is proved that O is on the bisector of angle A. Angle A, which is actually angle, which is a part of line AOD. So OD is perpendicular to BC. So it means that OD is the altitude, because for altitude it must be perpendicular to some base. So it is proved that it is on the bisector, and it is a part of a point O is on a part of AOD, and OD is proved to be perpendicular to BC. Not proved, it was taken as a step of construction. So OD was a perpendicular on BC, and we have proved that O is a part of OD and O is a bisector of the angle A. So by combining all these results, we can say that O is on the bisector of the angle ABC. Now we come to the next question, which is from exercise. Review exercise. Review exercise 12, question number 4. Quite simple. We are given a triangle ABC, and it is an equilateral triangle, and AD is the bisector of angle A, and we have to find X, Y, and Z. Right. So as ABC is is an equilateral triangle, and we know that in an equilateral triangle, all the sides are equal, so its all angles are also equal. And for any triangle to have equal angles, it's the only chance is that all the angles are of 60 degrees. So in any equilateral triangle, all the angles will ever be 60 degrees. They will be triangular. So therefore, angle A will be 60 degrees, angle B will be 60 degrees, angle C will be 60 degrees. So from here we can say angle Z is 60 degrees. But as we can say that X and Y, as AD is a bisector, so X and Y are a bisector of A. So X and Y will be half of 60. So they both are 30 and 30. So as because A is bisected into two angles, angle X and angle Y, so that is why they are 30, 30. Now we will see another question, and that is from review exercise 12, question number 5. In the given congruent triangles LMO and LNO, we have to find the value of x and m. So these two triangles in which we can see the sign of 90 degree over here at point O. So these are congruent. Initially it is given to us that they are congruent. As the triangles are congruent, so it means all their corresponding sides and angles are congruent. So it means that MO will be congruent to NO, as MO is equal to M, small m, and NO is equal to 12. So M is equal to 12 because the corresponding sides are congruent to each other. Similarly, this side LM will be congruent to this side LN. We can write this, and we can write the values over here. 2x plus 6 is equal to 18. And from here we can get the value. 2x is equal to 18 minus 6 is equal to 12, and x is equal to 12 by 2 is equal to 6. So that's all from unit 12 with a few questions, and the rest I'm leaving for the students to solve. I hope they're clear. Thank you.